In this video, we're going to see how to use scArchon. First, connect to the website. Once connected, we want to check whether we have the requirements, which are to have a GPU with CUDA 12.4 installed and Singularity with the version at least of 3.6. You can check your CUDA version going to the terminal and typing NVIDIA SMI. Here you see that we have the required version of 12.4. We can do similarly for the Singularity. In our case, we have a Singularity with a version above 3.6, so we're good to go. Once we ensured we have the requirements, we can go on with installing the environments required for scArchon to run. For this, we are going to create a Conda environment which is going to be called Snakemake env. In my case, I already had the environment downloaded, so I just need to activate it. We now ensure that we satisfy all the requirements and we have created the necessary environment. We're now going to git clone the repository into a given folder. The folders are now downloading. It may take a little bit of time. In the clone folder, you can see that there is a dataset which is called Kang. We can visualize it on a UMap and see the contents. We observe that it has condition with values controlled and stimulated, as well as cell type with all the cell types contained. We're going to need this information in order to set up our experiments, which can be done in configs datasets.tsv. We need to input the file path to the data, the observation condition, and the name of the corresponding values. Similarly for the batch, which is going to be the cell type, the target from which we want to get the prediction, the name of the experiment to save the files, and we can also select the output file and the tools to be run. In this example, we're going to use scPram. In the downloaded scArchon folder, we can now cd into it. We can activate the Snakemake environment, and we're going to use the terminal command in order to run the pipeline. When you run it, it is going to run the Snakemake, create the jobs to be run, and it's going to start pulling the Singularity image for the metrics environment, which is required in order to be able to compute the metrics, and of the tools that you have selected, in this case, scPram. The pulled Singularity images will be stored locally in .snakemake Singularity. They only need to be pulled once. This may take some time. In our case, the Singularity images were already pulled, and so we can go on and run the pipeline. When you run the pipeline, the different jobs are going to be printed. The Singularity images is going to be activated, and the different scripts are going to run by themselves. Once all the scripts have run, you're going to have a couple of results. If you go into logs, you're going to be able to see the running time of the experiment. Further in results, if you go to the experiment name that you gave, in our case Kang, and to H5AD, you're going to be able to see the saved H5AD files containing the results. In metrics, you can have all the different metrics that were computed. If you go to biology, you have a couple of information. You can look at the different dimension reduction visualization, and you can also look at the biology a little bit further, looking at the enriched terms, which are the true one, the predicted, and which are the commons, the different terms, and so on and so forth. This was the presentation on how to use scArchon. Thank you very much for your attention.